Section 358.10 of the National Electrical Code addresses wiring in traffic areas. Specifically, it outlines requirements for raceways in areas subject to physical damage. This includes locations such as parking garages, driveways, and outdoor areas exposed to vehicular traffic. The code mandates the use of robust raceway systems to protect electrical conductors in these environments. Acceptable raceway types include reinforced concrete encased in concrete. This provides substantial physical protection against impacts and crushing forces. Rigid metal conduit is another approved option. Its metallic construction offers high strength and resistance to damage. Intermediate metal conduit is also permitted. It provides a balance between strength and cost-effectiveness. Schedule 80 polyvinyl chloride conduit with Schedule 80 polyvinyl chloride fittings is also acceptable. The thicker wall of Schedule 80 provides enhanced impact resistance compared to Schedule 40 polyvinyl chloride conduit. The use of Schedule 80 polyvinyl chloride fittings ensures the integrity of the entire raceway system. Other raceways approved for the condition may also be used. These alternative raceways must meet specific performance criteria to ensure adequate protection. The fundamental principle is to safeguard electrical wiring from potential damage caused by vehicular traffic or other physical hazards present in these areas. The choice of raceway type depends on factors such as the severity of the physical hazards, the installation environment, and cost considerations. However, all selected raceways must comply with the minimum requirements specified in Section 358.10 of the National Electrical Code. Installations in traffic areas must adhere strictly to these requirements to ensure electrical safety and prevent damage to wiring systems. The code aims to minimize the risk of electrical hazards and maintain the reliability of electrical systems in potentially hazardous locations. It is essential to consult the latest edition of the National Electrical Code in local amendments for the most up-to-date requirements and interpretations. Proper installation practices are also crucial for ensuring the long-term performance and safety of raceway systems in traffic areas. This includes using appropriate supports, fittings, and sealing methods to maintain the integrity of the raceway system. Regular inspections and maintenance are also important to identify and address any signs of damage or deterioration. By following these guidelines, it is possible to create safe and reliable electrical installations in traffic areas that comply with the National Electrical Code and protect against physical damage. Failure to comply with these requirements can result in electrical hazards, equipment damage, and potential safety risks. It is therefore essential for electrical contractors, installers, and inspectors to be familiar with the specific requirements outlined in Section 358.10 and other relevant sections of the National Electrical Code. This will help ensure that electrical installations in traffic areas are safe, reliable, and compliant with applicable codes and standards. The use of reinforced concrete encased in concrete provides maximum physical protection for electrical conductors. This method is particularly suitable for areas where there is a high risk of impact or crushing forces. Rigid metal conduit offers excellent strength and resistance to damage. It is a durable and reliable option for protecting electrical wiring in traffic areas. Intermediate metal conduit provides a cost-effective alternative to rigid metal conduit while still offering adequate protection. Schedule 80 polyvinyl chloride conduit is a non-metallic option that provides good impact resistance. It is important to use Schedule 80 polyvinyl chloride fittings to ensure the integrity of the entire raceway system. When selecting a raceway type, it is important to consider the specific conditions of the installation environment. This includes factors such as the type and volume of traffic, the presence of chemicals or other corrosive substances, and the potential for vandalism. It is also important to consider the cost of the raceway system and the ease of installation. A qualified electrical contractor can help assess the specific needs of the installation and recommend the most appropriate raceway type. Proper installation practices are essential for ensuring the long-term performance and safety of raceway systems in traffic areas. This includes using appropriate supports to secure the raceway in place, using proper fittings to connect sections of raceway, and sealing the raceway to prevent the entry of moisture or other contaminants. Regular inspections and maintenance are also important to identify and address any signs of damage or deterioration. This includes checking for cracks, corrosion, and loose connections. Any damaged or deteriorated components should be replaced promptly to maintain the integrity of the raceway system. By following these guidelines, it is possible to create safe and reliable electrical installations in traffic areas that comply with the National Electrical Code and protect against physical damage. The National Electrical Code is a comprehensive set of standards for electrical installations. It is updated every 3 years to reflect changes in technology and best practices. It is essential to consult the latest edition of the National Electrical Code for the most up-to-date requirements and interpretations. Local amendments to the National Electrical Code may also apply. It is important to check with the local electrical inspector to determine if there are any local amendments that must be followed. Compliance with the National Electrical Code is essential for ensuring the safety of electrical installations. Failure to comply with the code can result in electrical hazards, equipment damage, and potential safety risks. It is therefore essential for electrical contractors, installers, and inspectors to be familiar with the requirements of the National Electrical Code. In addition to the requirements for raceways, the National Electrical Code also contains requirements for conductors, overcurrent protection, grounding, and other aspects of electrical installations. It is important to comply with all applicable requirements of the National Electrical Code to ensure the safety and reliability of electrical systems. Section 358.10 highlights the critical importance of safeguarding electrical wiring in areas prone to physical damage, emphasizing the need for robust raceway systems in locations like parking garages and driveways. The approved raceway types, including reinforced concrete encased in concrete, rigid metal conduit, intermediate metal conduit, and Schedule 80 polyvinyl chloride conduit with Schedule 80 polyvinyl chloride fittings, offer varying levels of protection to accommodate different environmental conditions and risk factors. When selecting a raceway system, consider the specific hazards present in the area, such as the volume and type of traffic, potential for impacts, exposure to chemicals or corrosive substances, and the risk of vandalism. Reinforced concrete encased in concrete provides the highest level of protection against physical damage. It is ideal for areas where there is a high risk of severe impacts or crushing forces. Rigid metal conduit is a durable and reliable option that offers excellent protection against physical damage and corrosion. Intermediate metal conduit provides a balance between cost-effectiveness and protection. It is suitable for areas where the risk of physical damage is moderate. Schedule 80 polyvinyl chloride conduit is a lightweight and cost-effective option that offers good resistance to impact and corrosion. However, it is not as strong as metal conduits and may not be suitable for areas with a high risk of severe impacts. Always use Schedule 80 polyvinyl chloride fittings with Schedule 80 polyvinyl chloride conduit to ensure the integrity of the raceway system. Proper installation practices are essential for ensuring the long-term performance and safety of raceway systems and traffic areas. Use appropriate supports to secure the raceway in place and prevent it from sagging or becoming dislodged. Use proper fittings to connect sections of raceway and ensure a watertight seal. Seal the raceway to prevent the entry of moisture, dust, or other contaminants. Regularly inspect the raceway system for any signs of damage or deterioration. Repair or replace any damaged components promptly. Consider the specific environmental conditions when selecting and installing raceway systems. In areas with high humidity or exposure to corrosive substances, use corrosion-resistant materials such as stainless steel or coated metal conduits. In areas with extreme temperatures, use materials that can withstand the temperature variations without becoming brittle or deformed. In areas with a high risk of vandalism, use tamper-resistant fittings and enclosures. Always consult with a qualified electrical contractor to ensure that the raceway system is properly designed and installed in accordance with the National Electrical Code and local regulations. They can assess the specific hazards present in the area and recommend the most appropriate raceway system for the application. Staying up to date on the latest edition of the National Electrical Code and any local amendments is crucial for ensuring compliance and maintaining electrical safety. The code is constantly evolving to reflect changes in technology and best practices. Section 358.10 underscores the commitment to electrical safety by mandating robust protection for wiring systems in areas susceptible to physical damage. Understanding and adhering to these requirements is essential for all electrical professionals involved in designing, installing, and maintaining electrical systems in traffic areas. Firstly, reinforced concrete encased in concrete is a suitable raceway because of its ability to withstand a lot of force. Secondly, rigid metal conduit is another suitable raceway because it is also durable. Thirdly, intermediate metal conduit is another suitable raceway because it is also durable and it has the benefit of being cost-effective. Fourthly, Schedule 80 polyvinyl chloride conduit with Schedule 80 polyvinyl chloride fittings is a suitable raceway for its resistant to impact. To summarize, it is important to follow the National Electric Code's recommendation when it comes to raceways.